All right. Well, I hope that everybody have a good Labor Day weekend. It
was so great.
was great.
Yeah.
Nice, nice, nice. So it's a short week. That's good. A couple things. Tomorrow, your homework is due. That's the standard deviation that I gave you last week. You'll have a standard deviation quiz on Thursday. We have a couple of lessons we'll talk about this week, starting today with normal distribution. We'll move on into scatter plots and linear regression. And then it looks like all of next week is going to be devoted to the chi-squared test for independence. It's not a difficult lesson, but there's a lot of information to convey, and it's probably one of the biggest strategies that people tend to use on their IAs. So, speaking of your IAs, did everybody get their IA topic paper turned in? Okay, if you don't have that ready, try to get that to me as soon as you can. Now, on Friday, we did turn in focus activities 1 through 3, so you'll notice this one starts what? This is number 4, so this belongs to the second set. So in a couple of weeks, when I have you turn in the current set of focus activities, you will not be turning in 1 through 3. We have already taken care of that. It's only the current ones. All right, so let's see here. So we have a maximum of 5 marks for this problem. This is a quadratic. A times x minus h squared plus k. What form of a quadratic is that? That's vertex form, where we see the vertex at hk. So it says the vertex of the graph of f is at 2, 3, and the graph passes through 1, 7. Write down the value of h and k. Well, that's pretty straightforward. What's h? H is 2. K is equal to 3. Now it says find the value of a. So I want the scale factor that's going to dilate this graph. How would I do that? Any ideas? So many hands up at once. I just need one. There you go. Now, I need to go ahead and plug in for x and y as well. Do we have some values there? There you go. So here's an x and a y point on the graph. Okay, so that'll take care of f of x and x. Then we have h and k. I'll have everything I need to go ahead and solve for the missing variable. So instead of f of x equals, I'm going to say y equals 7 equals. So we don't know what a is. So I want x minus h, so 1 minus 2 squared. And then we have plus k, so that would be plus 3. Okay. 1 minus 2 squared. Gosh, is 1. That negative is going to become positive. So 7 is equal to the 1a plus 3. So we see that a should be 4. All right, there we go. So if I'm looking at my vertex form, we ought to have f of x is equal to, well, we have the scale factor of 4, then x minus 2 squared plus 3. There we go. Okay, questions. How many people had the focus activity done before we started? A few folks. Okay. Okay. All right. Good, good. Any questions? Okay. Well, let's go ahead, put this to the side. Some place where you've been keeping the other ones. Make sure to keep them safe. That should be a guaranteed 100 for you. Now, your standard deviation homework is due tomorrow. We had ourselves a long weekend, so I thought, why not go ahead and start the lesson today with just a little bit of review. So let's say you have a set of data. Looks like this one here, 5, 8, 6, 9, 6, 6, 4, 7. Okay, let's say I wanted to go ahead and do this by hand. I'll go ahead and show you on the calculator as well. So the first thing I'm going to do is just list these out. 5, 8, 6, 9, 6, 6, and 7. Okay. Well, what's that mean, x with that bar above it? Okay. Oh, did I forget one? Oh, went right past it. 6, 6, 4, 7. There we go. Okay. So what's that refer to if it has the bar above the variable? That's the mean. That's the average. Okay, so let's see what we got here. I'm going to go ahead, calculate. All right, so I don't have the numbers in front of me. I'll just go ahead. I had it done a second ago. Of course, I had this, and then the bell rang, and where did I put it? Ah, here we go. All right. Okay. So let's see here. What do we got? 5 plus 8 plus 6 plus 9 plus 6 plus 6 plus 4 plus 7. That dang 4. Okay, so I got the set of data right here. Looks like grand total is going to be 51. What am I going to divide it by? 8. Okay. So 51 eighths, control enter. Of course it did. 51 divided by 8. Control enter. There we go. 6.375 is what I'm getting for my mean. Okay. Now, what I'm going to have you guys do is help me fill in the rest of the table. So have your calculators ready. Be going down the line. I need to take each one of these elements, and I need to now subtract 6.375. Okay, and then I'm going to take that difference. I'm going to go ahead and square it. Remember, if it's a negative, don't need to worry about that. Okay, it's going to become positive anyway. So I rounded mine to 4 decimal places. So for example, if you're following along in the calculator, if I take 5 minus 6.375, I got negative 1.375. And then if I square that, I got 1.8906. I'm just going to take it to 4 decimal places. Okay. So now let's start going around the room here. How about Nolan? I need 8 minus 6.375. $1.6 what? 1.625. What do I get if I square that? Two point what? 6406. Let's go ahead and take it to 4 decimal places. Because some of these go further, we're just going to go ahead and take that. Okay. Now, the good news is we have 3 6s here, so this is going to make it easy. John Henry, 6 minus 6.375. Okay, so this is going to be negative 0.375, negative 0.375, negative 0.375. And what do we get if we square that, John Henry? That's right. Okay, you're correct, except no negative. Okay, so 0.1406. 0.1406. 0.1406. Okay, 3 to go. 9 minus 6.375. How about, look. Okay, 2.625. Perfect. And Laura, what do I get if I square that? Okay, 6.89. And I'm going to go ahead and keep it to 4 decimal places. That's perfect. But 891, that would have been perfect. Okay, 2 left. Okay, Naya, help me out with 4 minus 6.375. Say one more time. Ooh, Lila, 4 minus 6.375. That's okay. No problem. Perfect. Negative 2.375. And what do I get if I square that? Okay. Well, now, if you round it to 1 decimal place, that's correct. You just need to forget the what? The negative. Okay. So I got 5.6406. And can anybody wrap this up for me with 7? 0.625 squared. 0.3906. Okay, now if I take the sum of those square differences, I got 17.8748. Okay, 17.8748. And if I go ahead and take that value right there, 17.8748. If I go ahead and divide it by the 8 total number of terms I had in the set, that will give me what we call what? That's the variance. Now, as soon as I take the square root of that, that's the what? That's going to be the standard deviation. That's the difference between the variance and standard deviation. And I think you should find that comes out to about 1.49. Okay. All right, so it's not bad. It can get a little monotonous. Again, I think it's important you know how to do it by hand. But now let's go to what's even more important, putting this in the calculator. So let's take this set of 8. Let me come on over here. You guys walk me through this. So I'm going to go back home. Okay. What do I do? Okay. New document. I'm going to choose list and spreadsheet. Okay, now is there anything that I avoid here? Okay, to avoid this row here. That's for the spreadsheet solely. Okay, so let me put in my information. 5, what was it? 8, 6, 9. Whoop. That really doesn't matter. I'll just switch those around. Okay, 6, 6. Oh no, 6, 6, 6. Okay, bless you. 4 and 7. Okay. Well, now that I got all my data in, what do I do? Okay, so I'm in an empty cell. Press menu. Statistics. This is one variable. It's just one set. Just click OK past that box. There we go. Change this to X, the title I put in. Even if you try to remove the frequency list, it's going to come back as soon as you get out of that box. So don't worry about that. Looks like everything's going to show up in column B. Click OK. And there we go. That is the 1.49 that we got by hand. Okay. Much, much faster on the calculator if you remember your keystrokes. Okay. Now that's fine if you have a set of data. Let me go ahead and give you a frequency table now. Okay. The weekly wages in dollars of 200 steelworkers are given alongside. Estimate the mean and the standard deviation of the data. Okay, so this is not only a frequency table, but the data has been grouped into class intervals. Okay, so this one we are definitely not going to worry about doing by hand because that would take quite a bit of time. So what do I do if I want to plug this in the calculator? What's the key to the class interval if I want the mean or the standard deviation? I want the midpoint. Okay. So what we need to do here, what would be the midpoint between 360 and 369.99? 364.995. Okay, very good. All right, so what I'm going to go ahead and do is come on over here. Okay, list and spreadsheets. Let's say X, frequency. Okay. Now, for this first one here, it was 364.995. Okay. And then it was going by tens, because that's how the intervals were set up. So 374.995, and let me just double check to make sure that is correct. Yeah, 74, 84, and it goes all the way through 434. Okay. So 384.995, 394.995. Of course it did. Okay. 394.995. There we go. That looks better. And then what would the next one be? 404.995. Okay. 413.995. 424.995. And I think it went to 434, right? Was that the last one? Okay. There we go. Okay. Now we come back up here and we just go ahead and put in my frequency values. Now I know what you're thinking. I did not make this problem up. It actually appeared that way from the resource I found it. Do you see what I'm referring to? 1738. I swear I didn't do that. It just happened to come up that way. So, you know, it's awesome. Okay, so 1738. What we got here? 1738. I think the next one's 47. Then what do we got? 57, 18, 57, 18, 10, 10, and the last value was 3. Okay. There we go. So I've got first column is my midpoints of the class intervals. Second column are my frequency values. Now how do I find the information I want? Okay, menu, statistics, stat calculations. Now wait a minute, I got two columns. It's still one variable. Remember, the frequency just tells me the number of elements in that particular class interval. All right, so this is still just one set of data. Okay, so one variable statistics. Click OK past that. This one we have to choose both of these. So for the X list, I'm going to choose X. For the frequency, I'm going to go ahead and choose frequency. Looks like it's going to appear in column D. And here we go. I would say it's about 15.9. Okay. So a much higher standard deviation than the other one. What is standard deviation anyway? What is it telling me? It's a measure of spread. Okay, so the lower the standard deviation, what does that mean about the elements in my set? The closer they are to each other numerically. The larger the standard deviation, the wider the spread, the bigger the differences between those. Okay. And the mean, if I were just to come up here, looks like the mean is going to be 390.3. Okay, if I were to go ahead and round it. All right. Question. Okay, so you got a quiz over this coming up on when? Thursday. And the homework over this is due tomorrow. So we'll come in first thing, talk about any questions you may have had, and then we'll just continue with our lesson, which we're going to start right now. Okay, normal distribution. We very, very briefly saw this in the very first lesson, but now we're going to go into it in a lot more detail. You've got symmetrical distribution. Now, each one of these is going to provide a certain relationship with your measures of central tendency. For example, if your data is normally distributed, okay, if it has that bell-shaped curve to it, this is where the mean, the mode, and the median will all be the same value. Okay, the mean equals the mode equals the median if it's normally distributed. Now, there are ways, if your data isn't normally distributed, that you can essentially force it to be normally distributed, because we like data to be normally distributed. And here, we're always going to believe our data is such. Okay, so one thing IB is not going to ask you to do is to make your data normally distributed. We're always going to believe that it is. Is everybody okay with that? Anybody here in a stats class with Mr. Reeves? No. If you do choose to go in there, he's a great teacher, but he will be showing you those aspects of statistics. We're not worried about it in here. Now, you'll notice this one here, this is a negatively skewed distribution. If it seems to pull to the right, this is where the mean will be the lowest of the three values. The mean is less than the median, which in turn is less than the mode. So the mode is going to be the largest value, as opposed to a positively skewed distribution where it's pulling to the left. In this case, the mode is going to be the smallest value. The mode is less than the median, which is less than the mean. Now, normal distribution is a special type of symmetrical distribution. In a normal distribution, the mean, median, and mode are equal, just like I had written out there. Now, these percentages are going to change. If you're in a stats class, then you're going to use those exact decimals. But IB, you know, as I've said many times before, kind of does things a little different. Jaylee? Do you have your card? Go very quickly. But then get a card. Okay? So we're not going to worry about the 68.3, 95.4. We're just going to go ahead and say 68%, 95%, and then 99.7%. This refers to the amount of data below the curve that we're looking at. Okay? So we're going to change this up a little bit here. So 99.7 is virtually almost all of the data that you have. So we like to go ahead and look within 2 or 3 standard deviations of the mean. The mean is always the value that's in the direct center of your graph. And then you add the standard deviation going up, and you subtract the standard deviation going down. Okay, so let's say within 1 standard deviation, if this right here is meant to be 68%, well then what would the percent of that area be? 34, remember this is symmetrical, so the two areas should be identical to each other. So this is going to be 34%, okay? And we're just going to continue to work our way out. Within 2 standard deviations, that's supposed to be 95% of the data. Okay, so now we've already accounted for 68% of it, right? So what's the difference between 95 and 68? 20 what? Okay, so 95 minus 68, 27. Now, these 4 areas should add to 95%, but remember it's symmetrical. So these 2 are identical, these 2 are identical. If this is already 68%, I know the difference is 27, then what should the percentage for each of these little areas be? 13.5, just half of 27. So 13.5%, 13.5%. There we go. Now, below the curve, within 3 standard deviations, you should be able to see 99.7% of the data. Okay. So again, we'll just continue to work our way out. We've already accounted for 95% in these 4 areas right here. 13.5 times 2 plus 34 times 2. Okay, so 99.7 minus 95. Okay, hello? Okay, 4.7? Okay, now, what's half of 4.7? 2 point what? I heard it, somebody said 2 point, I'm old, yes, we go. 2.35, there we go. So this little area right here is 2.35%. This little area is 2.35%. So don't worry about the values that are on there. This is how we're going to be looking at the percentages of your data. Okay. So let me go ahead. Okay, where I'll show it to you in just a second. Let's just get right to an example. Let's see what you think. The chest measurements of 18-year-old male footballers are normally distributed with a mean of 95 centimeters and a standard deviation of 8 centimeters. Okay, now mean, we use this symbol mu right here. Okay, and for the standard deviation, remember we use that lowercase sigma. Looks like that curly O. Okay. Draw a normal distribution curve and label it with the mean and 1, 2, and 3 standard deviations above and below. Okay, well, a normal distribution curve is that bell curve that we were just looking at, just like that. Okay, so right here in the middle, at the very center, you're always going to put the mean. Remember, this is where the mean, median, and mode are all identical. So I'm going to put a 95 right here. So now I'm going to go 1, 2, 3 standard deviations above, and then I'm going to go 1, 2, 3 standard deviations below. But what is the standard deviation? Okay, 8 centimeters is my standard deviation. So what I want to do for the markings above, I'm going to continually add that value 8. So what's 95 plus 8? Okay, so 103 plus 8. 111 plus 8. 119. Okay, and now let's go back the other way. I need 95 minus 8. 87 minus 8. 79, and then 71. That's all it takes to go ahead and create your normal distribution curve. Is everybody okay where I got those values from? Okay. And hopefully it makes a little more sense if you're looking at the top of your paper, because below this, it says the mean plus the standard deviation, the mean plus 2 standard deviations, mean plus 3, and then you're subtracting those in the opposite direction. Okay. Now it says find the percent of footballers, okay, with chest measurements between 87 and 103 centimeters. Okay, so I'm going to go ahead and shade the area starting at 87, and I'm going to go all the way to 103. Okay. Well, think about the percentages as we just put them below the curve. Those two identical regions together within one standard deviation, it's always what? It's in the 60s. What is it? 68%. So if I were to look at all of the data, if I put them from the smallest chest measurements all the way to the largest chest measurements, okay, well, how many are going to fall between 87 and 103 centimeters? It should be 68% of the data. Because I'm just adding up the areas knowing those below the curve. Okay. Let's try 2. I want to know between 103 and 111. Okay, so let me do this one in green. 103 and 111. So that's this one right here. Okay. So look back at the diagram we just had a moment ago. What percentage of the players should fall in that green section? Should be 13.5%. That's it. That's all there is to it. There's no trick. It is just that easy. Okay. Anybody not sure how I'm getting these values? Okay. You want to try the last one on your own? Sure. Okay. Let's do this. Find the probability that the chest measurement of a randomly selected football player is going to be between 87 and 111. 87 and 111 centimeters. Okay. Amy, can you help me out with this one? That's it. 81.5. Okay. We want to know the number of players, the percentage between 87 and 111. So now we're looking at this whole area, all 3 of them that we had previously. So yeah, just take the sum of the 2. 81.5. Okay. So what if I asked you another one, let's say just randomly? Let me go ahead and use purple this time. What if I wanted to know the percentage of the data that had chest measurements between, let's say, 71 and 79? What would that be? Okay, same man? Oh, not 13.5. Okay, that would be 2.35. Okay. Because look at the regions below the curve. We've got 3 above and we've got 3 below. Okay. It goes 34, 13.5, and then 2.35. Okay, for a grand total of your 99.7%. Okay. Now, these problems are really easy if you're trying to find questions based on the actual standard deviation. But a lot of times, how often do you think it's going to be in the real world where we take a set of data that's normally distributed? Will the questions always be exactly what we need? No. So that is where this next part's going to come in. Okay. So in most instances, we will not be lucky enough to be looking for probabilities that are 1, 2, or 3 standard deviations from our mean. To determine the probabilities for these situations, we can use a table of standardized normal values. Okay, so once upon a time, IB did require that you do this by hand and go ahead and use what's called z-values. Okay, big tables of numerical values that you would have to look for and find those percents that you're looking for. Luckily, they've since changed it. We don't have to do that. So go ahead and mark out this little thing that's talking about z-scores. If it's not an exact standard deviation like the previous problem was, this is going to be taken care of entirely on the calculator. Okay, so let me show you what it means. Using the information for footballers above, determine the probability that a randomly selected footballer has a chest measurement between 88.2 and 94.7. Okay, so let me recreate this very quickly. The graph that we just had a moment ago. Okay, so that way I don't have to keep going just back and forth. Okay, the mean was 95. Okay, that was the average chest measurement for these football players. And then what were the 3 standard deviations above? It was 103, 111, and then it was 119. Because we had a standard deviation of 8, right? Okay. Now let's go back in the other direction, but going below that, we're going to subtract. So what values did I get there? 95 minus 8 was a 87, 79, and a 71, right? Now this question wants to know, okay, what's the percentage of the data that would fall between 88.2? So let's say 88.2 is right about here, just a little bit past that 87, and 94.7. So it's almost to that mean. So I'm looking in this region right here. See, there's no way to do that by hand without knowing about the z-scores. Okay, if anybody wants me to show you those, I mean, I can at some point. You are not going to be tested on it. You're not going to be required to know it. So typically students don't ask about it. But let's go to the calculator. Okay, so let's see here. What we're going to do, I'm going to go to your calculate screen. Oop, I think I'm going to have to do this on the mouse. Okay. Okay. So let's come on over here. Okay, calculate. All right, let me go ahead and just document B out of here. Now, what you want to do if you want to find the percentage of your data below a normal distribution curve, I'm going to hit menu. Okay, I'm going to go to statistics. Where do you think I'm going to go from here? Remember, what's the name of our topic today? Normal distribution. So we want to go to 5 distributions. Okay. Then you're going to have another one come up. Now you've got 2 normals. You got normal PDF and you've got normal CDF. You want CDF. Okay. Normal CDF. Okay, so let me get out of here real fast. Menu, where'd I go? Statistics. We have normal distribution, so distributions. PDF or CDF? We want CDF. Now, when you click it, it's going to have 4 little boxes for you to fill in. Okay, you've got a lower bound, you've got an upper bound, and then you've got the mean and the standard deviation. Okay, well, let's go ahead and plug in the mean and the standard deviation. Remember, that was 95. The standard deviation was 8. Now, take a look at your paper. Okay, we want to know the chest measurement between these 2 values. So what do you think 88.2 is? That's your lower, so 94.7 would have to be your upper. You want everything between the 2. So we're going to have 88.2. Let me go ahead and get rid of this. And then the upper was 94.7. Okay, so I'm going to click OK. It's going to have everything set up for you. So 0.28738. Now, that's the decimal value. What is it if I convert it to a percent? So we're looking at about 28.7%. Okay. About 28.7%. There we go. And does that kind of fit with what we got in our diagram here? What should this whole section be as a percent? It should be 34% max, okay, within that 1 standard deviation. So I'd say 28.7, you know, we're really close to those boundary values. Okay. Now, there's only one thing when we're looking at these other ones. Okay. Now, same question, but has a chest measurement smaller than 96 centimeters. Okay. So let me go back over here to the calculator. Now, no matter what type of question you're being asked, you always use the same keystrokes. So I'm going to go back over here. Okay, so I went to menu. I forget again, where was it? Statistics, distributions, normal CDF. Okay. Now, what would you say this value is right here? We want smaller than 96. Would you say 96 is the upper or the lower? It's the upper. Okay. Now, when you come over here, I'm going to go ahead and put in the upper. Well, you'll notice every time you pull up this normal distribution, a lower is already input for you. So see, negative 9E999. What does that E mean? There you go. That's standard deviation. Okay, that means we're going to raise it times 10 to the 999th power. So this is going to be an incredibly small decimal. So if there is no lower boundary, just leave that one in as is. Okay. Now the mean was 95. What was the standard deviation? 8. Okay. So I'd say we're looking at about 54.97. You could probably just go ahead and say 55%. 55%. Okay. So let me use a specific color on this one. All right. So we wanted everything less than 96. So how about I go ahead and use green here. So 96 is going to be like maybe right here. It's going to be super close. So what percentage is less than that particular mark? We found that to be about 55% of the data. Is everybody okay with what I'm doing? Is anybody confused? No? Okay. Now, let's go ahead and take a look at C right here. Now, what is the probability that a randomly selected footballer has a chest measurement smaller than 86.4 or, and that's the key word here, larger than 102.5? Okay. Now, I'm basically looking for this percentage right here. Let me go ahead and do this one in purple. Okay. So this whole thing is going to be done in purple. So 86.4, let's say that's about right here. Okay. I want everything less than that or larger than 102.5. So 102.5, maybe right there. Okay, we're kind of estimating. Okay, so we're going to go ahead and do these separately. We're going to have to use the calculator twice. This one's going to give me a percentage. This one's going to give me a percentage. Well, what am I going to do to get the final answer? I'm going to have to add the two together. So basically, what's the total percentage of it being less than 86.4 or larger than 102.5? Is everybody okay with that? Okay. So what would you say 86.4 is? Is that your lower or your upper? Okay, that's your upper because you want everything smaller than that. So let's come on over here. Menu, statistics, distributions, always normal CDF. Okay, so leave the lower bound. What was it, 86.4? Is that right? 95 and then 8. So what should I be getting when I push OK? I got 0.141187. Is that what people are getting? Okay. Now, I haven't shown you how to do the other one yet. Now, let's go ahead and plug him in. What would you say 102.5 is? He's the lower boundary. Okay, you always have to have an upper and a lower boundary put in. Now, if you're given the upper boundary, leave that scientific notation as is. It's always going to work out for you. But what if you have a lower? So let's see. I'm going to go to menu, statistics, distributions, normal CDF. Okay. So the upper, what was it, 102.5? Oh, no, I'm sorry. The lower was 102.5, excuse me, 102.5. Now, if you have a lower but no upper, it sounds funny and it's going to be ridiculous. Just put in a ton of 9s for the upper, just like you had a ridiculously small decimal for the lower. Okay? So no matter what, you have to have an upper and a lower put in. If you're only given one, you'll either leave the lower or put in just a ton of 9s for the upper. Okay, then we still have a standard deviation of 95, or excuse me, a mean of 95 with a standard deviation of 8. So on that one, I'm getting 0.174251. Is that what everybody's getting? So now all I got to do is take the percents that I previously got and just combine them. So what percentage is going to be less than the 86.4 or bigger than the 102.5? I'd say about 31.5%. Probably make an argument for 32%. Okay, about 31.5. That's it. That is normal distribution. 31.5%. Okay. So if the values, the questions are asking you specific values at your standard deviations, you just need to know the percents of the data below the curve. If it's not those exact standard deviations, calculator's going to take care of that. Those are the only two ways you'll be working it. Okay, does anybody have a hard time? Anybody not understanding? Okay, actually there's only a few more problems left, but it looks like we are just about out of time. So we are going to stop there for today. All right. Good.